So in the last lecture of this sine board structure, we will discuss that by adding these plan bracings, what is the effect on the mode shape of the sine board. So we go to display and deform shape. We select the primary mode, that is fundamental mode. Here now the time period is 0.738 and the behavior is somewhat like this. That is, the first mode is itself a torsion mode and it is opening closing mode. Here you can see that the ends are opening as well as closing. So as it is a cantilever structure, so these type of behavior do happens. And then we will discuss the second mode. The second mode is a translation mode. That is, the sine board is translating along the y-axis, whereas in this case the first mode is a torsional mode. And then we will check the third mode. So this is the combined behavior. That is, first mode is our torsional mode, second mode is a translation mode along y direction, and third mode is the translation mode along x direction. The fundamental time period is 0.738, which decreases to 0.237 and then decreases to 0.214. So although this type of behavior is not desirable, but what we can do here is that we can have some sufficient margins in the design, and as this is a cantilever structure, so this type of behavior is somewhat predicted, and this is a very, very beautiful mode shapes that should have been in the first and second mode, but in second and third then it's okay, not a big deal for such a very small structure. And if we want to check the mass participation factors and response spectrum, load combinations and what are their values, then we need to check the model results, we need to check the reactions, and if we want to calculate the material list, then what we can do here is that we can check the base reactions here. The seismic load case is approximately 5.6 and RSX is approximately 5.3, and it is 5.6 and 5.3 again. So almost the ELX and RSX are of same value, so the RS response spectrum load case does not need to be scaled. And after that we will check the mass participation factor. In the fundamental board, the mass participation factor is very less. It is approximately 0.9%, and in the second mode it abruptly increases to 95%, and in the third mode it abruptly increases to 96%. So first mode is not showing a very good behavior here. So what we can do here additionally is that we can add more bracings so that the structure is more confined and it should behave as a very good structural arrangement in the first mode. So add as much bracings as possible in the structural steel arrangement when this type of behavior is being shown. Although the mass participation factor in the last mode is 100%, and after that we should check the frequencies also. Frequency is also very high here, so we don't need that much amount of modes. We only need approximately 5 number of modes, that is up to 28 Hz frequency. 44 Hz frequency is not allowed as per the Indian standards, so we can also decrease the number of modes to 5. And after that we can check the material list also. we can export that to Excel. The total weight is approximately 42 kilonewton, that is 4.2 metric ton. And we can easily prepare the bill of material by copying by just like checking all this data and providing the client with all this quantities. So this concludes our lecture on the sine boards. Hope you have learned all the fundamentals of this, how to model and how to analyze and how to design the sine boards or the banner structures.